Meet Pete. Pete doesn't know it yet, but in 3 hours and 41 minutes at 7:43 a.m., he will be rushing his pregnant wife Abby to the hospital. He won't be thinking about whether his car is charged and able to safely cover the distance from here to there, because the engineers who designed and built Pete's car already thought all about it. SAE International assembled a team of engineers from all over the world to think systematically about the charging of Pete's car. These engineers developed a series of standards that made mass production of Pete's car safe, affordable, and environmentally sustainable. But Pete won't have to think about any of that. He's probably never even heard of us. And we're fine with that. Because in helping the engineers keep Pete's car fully charged and safe, we've done our job. Sleep well, Pete.
Hello, everyone. I'm Fabian Koark, the head of the Competence Center for Software Development at CARIAD. So special thank goes here to the invitation to the SAE Detroit Section for hosting this event, and also kind of showing already in the little introduction video part of the work that I'm focused on in my day business. But that's not why we're here. So we thank all you for attending today to the presentations of the 2022 GAMIC winners. Before we go into the program of today, I would like to mention a few housekeeping items. Please, if you join or just joined or will join, please stay muted and keep your camera off for the integrity of this meeting. This meeting, as you might have recognized, is recorded. That also means if you drop out of the meeting or you have to go to a different meeting and cannot further attend, you can also watch this video later on the Detroit Section YouTube channel. Please use for your discussion, for your questions, the chat functions of this Zoom meeting. We will use the questions that you're posting afterwards in the discussion. Today, we will be hearing the presentations of the 4 GAMIC, or the 4 winners of the Global Automotive and Mobility Innovation Challenge. This challenge is existing since 2008. There are many supporters on the voluntary side of this competition. I'm an organizer, I believe, for now 5 years, but there are many, many more judges and coaches that are supporting GAMIC. With this support structure, GAMIC is able to put prices together, in-kind services, and also small cash prizes with a total amount around $300,000 that shall and did support and accelerate the winners in these mobility startups in the past and will accelerate them in the future. That's what GAMIC was founded for, as a catalyst, as an accelerator program for especially early on mobility and automotive startups, often called pre-seed startups. Today on stage, we invited the winners of this year, of this season, and first for presentation and later on for discussion. And please make sure that you post your questions at any time over the chat function. Let's not wait any longer, and let's get Michael Burz from Enzinc here on this virtual stage and give him time to present his technology and his company to us. Thank you, Michael. We are curious to get an update from you.
Well, thank you, Fabian, and it's an honor to be here with all of you from around the world in SAE. So thank you very much for the opportunity. As Fabian said, Mike Burz, president and co-founder of Enzinc, and today I'm going to introduce you to an advancement in battery technology based on zinc. So as we all know, there are 2 major batteries that basically dominate the battery marketplace today. There's lead acid and there's lithium ion, but both of them have 2 functions that we need to take a look at. One has to do with toxicity, and the other one has to do with thermal runaway. And we're going to address those. So if we take a look at the battery marketplace today, it turns out that in that arena, there are two areas that we want to challenge. One has to do with the energy and safety. So I want you to leave the meeting today with these three major items. The first is that this zinc microsponge that we're going to introduce you to makes a better battery. In fact, it can replace lead acid batteries. The second is that we can take existing lead acid factories and adapt them with drop-in technology to convert them to making a high-tech zinc-based battery at 1/10 the cost of trying to make a lithium-ion battery. And that the material itself that is used to build the batteries are abundant, safe, low cost, and just as important, they're recyclable. So the United Nations has shown that by 2030, they project that most people will live in an urban environment, and that growth is going to come in Asia and India, the subcontinent, and Africa. Most of those companies or countries use lead acid batteries as their baseline. In fact, you know, the 800-pound gorilla in the room is lithium-ion batteries. We can't forget that the 700-pound gorilla in the room is lead acid. It is the most ubiquitous battery in the world. What we're going to do is take a look at a technology that basically then has the energy of lithium-ion at the low cost of lead acid, but is safer to use and has a wider temperature range than both. The platform we've developed then allows us to extend that for major marketplaces. We'll talk about some of those. The technology has been validated with a US Department of Energy award, and our funding at the moment is under development from the California Energy Commission. And as part of that testing that we're doing, we have an input from a world-class industry advisory group. There's about 10 companies that are advising us at the moment. 4 of those are multi-billion-dollar companies that are interested in the technology and are part of our test program, ranging from potential customers, which are battery companies, to partners, which are both in the mobility space, in the stationary energy storage space, and the recycling space. So why zinc? First looked at by Thomas Edison in 1901. The problem was Mr. Edison did not have access to a scanning electron microscope and couldn't see that dendrites were forming rapidly. And that was kind of causing the battery to have a very limited cycle life and limited applications. But Mr. Edison and the people that followed him in developing zinc had the right material. They just had the wrong form, as we'll see. So what are some of those advantages? Well, you can get high performance and high energy from it if you have the right form. It's very low cost. It's about $2 to $3 a pound. Because of the water-based electrolyte, we have an extremely wide temperature range, much greater than lithium ion, more equivalent to lead acid. There is no thermal runaway, so it's very safe. We can use it in vehicles as well as highly dense urban environments. It's the 4th most mined metal on the planet, and it's fully recyclable. And with this form that we're working with, we can offer then a platform solution to battery technology. So quickly, how does this eliminate dendrites, which gives zinc both the performance and the cycle life that it can achieve? Well, today, typically we have a zinc particle suspended in a paste, and on discharge, it gets surrounded by zinc oxide, which acts as kind of an insulator over time. What that means is that batteries today, which use that kind of approach, then each particle gets insulated from the others, meaning that the current flow during charge and discharge gets impeded. That current, as it goes through smaller and smaller channels, ends up with hotspots, which generate dendrites, and in zinc, they generate very, very quickly. What we in the Navy did is reimagine this as a 3-dimensional sponge structure, much like the sponge on your kitchen sink, but at the micron level. And what that does is it means that the zinc oxide that forms basically is on the outside of the sponge, leaving the inside pure zinc, which acts as a continuous current collector. No impeded flow of current, no hotspots, no dendrite growth. And therefore, we now can offer a high-performance battery with multiple cathodes. We've decided to use first nickel. So let me show you where that positions us. Everybody knows the lead acid battery, which is there in the corner. You can look at it by the x-axis, the horizontal axis. The further to the right you go, the lighter the battery. On the vertical axis, the higher up you go, the smaller the battery. And so lead acid has been predominant there in the lower left-hand corner. Nickel metal hydride, popular in vehicles like the Prius, is a little bit better. And of course, lithium ion, ranging from about 100 watt-hours per kilogram to 300 watt-hours per kilogram. Other zinc batteries which use different approaches are limited to about 2 times lead acid, similar to nickel metal hydride. Our technology that the Navy was interested in puts us more in league with lithium ion. But as we'll see, we can build it much cheaper. Just kind of overall, when we take a look at the advantages, the lifetime cost, we're about 1/20th that of lead acid, about 1/3 of lithium ion. Equivalent weight to lithium ion batteries, about 1/3 that of lead acid. The temperature range is equivalent to lead acid, and the cycle life more equivalent to lithium ion. So where have we been in our development? We started off with the Navy about 10 years ago. It takes a long time to develop a new technology. We then got an exclusive license to the technology from the Navy. Once it was patented, we established our lab here in Richmond, California, with funding from the California Energy Commission. We've then tested the battery at the small level. It's about the size of a dime, then moving to the size of a quarter. That allowed us to then attract the attention of an e-bike manufacturer as a potential customer, and then additional money from the California Energy Commission to test those cells. We then scaled those cells to the size of a quarter, and that performance then attracted a potential partner for nickel cathode supplies. We've now scaled once again, which is important for battery technology, to be able to scale it to the size of a dollar bill. And we are now building pouch cells that we can put into our prototype e-bike battery as our first deliverable. You can see there where we formed the IAG late last year. That is now in full force. I wanted to show this picture because this battery, the cells, the anode that we build can be handled by people and by robots, which is really important for our manufacturing. We're looking for pre-production in 2023 and low-rate initial production in 2024. So the competitive landscape, which we're taking a look at, really, if you take a look at the lower right-hand corner, there's all the lead acid batteries, which basically are low cost but low energy. And in the upper right-hand corner are the competitors within the zinc battery world. Those fall into 2 camps. One is dendrite suppressing additives. They slow them down, but they don't get rid of them. And the other is flow batteries. The dendrite suppressing ones, you get pretty good cycle life, but you're limited in the energy, maybe like I showed earlier, about twice. And the flow batteries, you end up with long cycle life, but batteries the size of refrigerators or shipping containers. We're the only one that can deliver that kind of energy equivalent to lithium ion, but for both mobile and stationary applications. But I'd like to introduce a concept that these people in the lower right-hand corner are really not our competitors. And we'll talk about that in just a second. Because if what you can do is take those existing factories and convert them from making lead to making high-tech zinc-based batteries, then you've got a scalability advantage, which means we have a drop-in technology. We can reuse 75% of their factory infrastructure. We can reboot that market with a robust supply chain. What that means is that for about 1/10 the cost of trying to build an equivalent lithium ion plant, we can then convert that plant to building nickel zinc batteries with an equivalent revenue stream and take advantage of that existing widely deployed lead acid factories in every country. The business model is kind of like an Enzinc inside, kind of like Intel builds chips and helps computer companies take advantage of those chips and then supplies millions of them. We'll be doing the same. We'll design the battery and then we'll supply the anodes, millions of anodes. And what we get then is an advantage in the industrial partner, the lead acid company. We get their large scale manufacturing, their established sales and distribution, and their warranty and brand support. So what we're going to look at is that $60 billion market in lead acid. We've identified about $23 billion of opportunity within internal combustion engines, urban electric vehicles, things like e-bikes and delivery vans, uninterruptible power systems in the stationary arena, and microgrids. We're looking at our funding profile showed here, but we're basically looking at cash flow positive in about 5 years and break even in about 7 years. We have a very experienced team as part of our development. Myself, an engineer and working in high-tech development. Our CRO was at McKinsey and Enphase in the energy business. Our chief engineer was head of R&D for Electrovaya lithium-ion batteries, as well as Fisher Cast, which does or did zinc batteries. And our head of operations has over 30 years experience in the battery business as senior vice president for Trojan Battery, one of the largest lead acid battery companies in the United States. We also have in the senior advisor group, fantastic experience in high tech. Two I want to point out, Tim Stanley, former chief patent counsel for Sandia, and Stefan Sieberth, former president of Bosch Mobility and Powertrain Systems. So in summary, we have a strong demand with a large market. We have strong customer interest as evidenced by our industry advisory group. It's a patented technology that we have an exclusive license for, a very experienced team, low risk manufacturing approach, and we're looking then to top off our round. We've got a Series A round we're completing. We've already raised $3 million. We're looking to top off the last $1.5 million. Our exit strategy is either a public offering or a SPAC or an acquisition by one of those industry people. So thank you very much, and I look forward to your questions.
Thank you, Michael. I think that was pretty exciting what you showed, not just from a technology perspective, but also, I believe, from a business approach. So thank you for now. We're coming back to the questions later. We will stay in the e-mobility space. We just saw great technology in a battery space and electrical energy storage. Now we move forward and look a little bit deeper in the field of EV charging. And so I'm pleased to call Chris Cardé from HeyCharge on our virtual stage today to present the HeyCharge technology. He's founder and CEO.
Hi there. Thank you very much, Fabian. Hopefully you're now seeing the screen.
We do.
Perfect. So hi, yeah, thank you for the intro. I'm Chris Cardé. I'm the founder and CEO of HeyCharge, and so I'm here to tell you what we're doing to democratize access to EV charging in traditionally underserved environments like apartment buildings. And so the market here is huge. We've seen estimates that about 80% of EV charging will take place in private and semi-private environments, such as apartment buildings, offices, private homes, etc. Like private homes, they have it easy. They only need a dumb charger that just basically takes power from the wall and puts it in the car. But these semi-private environments have multiple users and require a so-called smart infrastructure. That's in order to identify the user, measure what they consume, and report this all to a management platform to build a user. And the dominant technology for this today is a classical IoT architecture, and that works reasonably well for public charging, but it has numerous problems when applied to semi-private environments. And these problems include reliability, complexity, and cost. And I'm going to get into exactly how that happens. But first, what is our solution? Our unique and core innovation is a patent-pending technology that we call Secure Charge. And what we do is we replace the permanent infrastructure-based internet connection at each charger with communication relayed via our users' smartphones running our mobile app. So our system communicates asynchronously, and that means that not only do we eliminate the cost drivers of the internet connection, but we're also solving the problem of mobile network coverage in the underground environment. So when the user is above ground, the app synchronizes with our backend in the cloud. And then when below ground, the app has all that cryptographic data necessary to unlock its next charging session with any charge point that user has access to. And that's why we call it secure charge. And, you know, we put secure in the name of the technology. So this is kind of like the detail view for the security enthusiasts in the audience. Here's how it works. We basically treat the mobile app as an untrusted environment. So we generate a series of single-use tokens on the back end, meter these out to each user, and we only replenish those tokens in return for the consumption data returned from each device via the user's app. And so in this way, we're secure against like all sorts of attacks, including replay, man-in-the-middle, reverse engineering our Bluetooth protocol, or our app source code. And kind of the intention here is to be able to put tens or even hundreds of millions of our devices into the field as secure energy sales and reporting endpoints. So why do we do this? We provide up to a 47% reduction in the total cost of ownership of a multi-user EV charging installation. The communication costs, as you can see, and it kind of makes sense, they disappear completely because you don't need communication to the site. The backend cost is substantially reduced because our backend is exceedingly efficient to operate. The hardware costs are reduced because our whole stack runs on a $2 wireless SoC. Kind of compare that to a Raspberry Pi grade embedded system. And the installation costs are dramatically reduced. We'll get into that here. This is the status quo. This is the graphical depiction of how legacy technology, you know, the EV charging installations you'd buy from other people today, this is how it's installed. And like the short story is, it's a lot of steps. And numbers 1, 2, and 4 are directly related to the fact that you have communications. And so by contrast, we can offer this. Our system is fundamentally plug and play. The cryptographic keys are assigned and recorded in our backend as the devices roll off our manufacturing line. And that allows us to pre-configure each charger onto a user account as it leaves our warehouse. So basically the user's app already has all the necessary equipment to configure and access that device the moment the electrician turns on the power. So that really saves a lot of steps and a lot of hassle. You can, of course, just invent a new way to manage EV chargers and not actually build both ends of the system. So, you know, we actually have a vertically integrated stack, including hardware. This is our European slide. I just realized the audience is probably a little bit more US focused here. We actually have a US hardware portfolio as well. I'm so sorry, I have the wrong slide in here. The US product also looks pretty cool. The first product on the left is Access Point, and this is basically an access controlled metering power outlet. This can do 3.7 kilowatts in Germany or all of Europe, and then up to 9 kilowatts in the US. And this kind of doubles down on the low cost of our secure charge technology with a bring your own wall box architecture. So this is kind of a super great way to push down the total cost even lower. Basically, the wall box is bought by the tenant, and then the landlord basically buys this platform, this hardware, to provide access control and billing only on the building infrastructure side. And you can see in the middle, we have a complete wall box. In Europe, that's 7 and 11 kilowatts. Our US version will go up to 48 amps, and that's also enabled with our secure charge technology. We also provide a secure charge module, and this is a part of our hardware platform. This can be integrated into any existing wall box design. And the small secret, we actually use it in our own HeyCharge wall box as well. And this is a huge enabler for the platform. So you've heard me mention the platform, and let's kind of go into what I mean by that. We started off HeyCharge with this vision for a beautiful product and user experience for people in apartment buildings, and we built exactly that. So we provide our app, our hardware, and our own energy sales as a turnkey vertically integrated value proposition for property managers and operators. And this runs under the HeyCharge brand. And basically, this is what we call the full service business. And kind of the key there is that you have HeyCharge brand and you have HeyCharge energy. But we realized that fundamental innovation of secure charge, the idea of having EV chargers with no internet connection, the cost of advantages, the ability to use this underground or in other low connectivity environments, that was too valuable to keep for our own first party product. So basically, we had industry players from energy, mobility, and automotive all coming to us asking how they could basically build those USPs, build our technology into their products. So we built a B2B platform, including an SDK, APIs, white label hardware, and our own module as a hardware development kit. And now our platform customers can enable their own first-party charging experiences with our best in the market cost and user experience. This is kind of a breakdown of who we are working with today and kind of how they map to full service and platform operating models. And the common elements here are that full service operators allow their customers to see the HeyCharge brand, and HeyCharge is the seller of energy at the site. And platform customers are kind of the opposite. They build HeyCharge's technology into their own product under their own brand. And with basically one exception, I'm not going to say what it is, we have examples of each of these in our sales pipeline today, some with commercial contracts, some with active pilots. So let's take a look at the unit economics. We operate the B2B platform globally, limited only by hardware certification in various regulatory domains. And this is kind of a low ARPU business, but with high scalability and high margins owing to our low cost of serving. But the full service business is active in Germany and the United States. The ARPU is substantially higher, but the scalability is limited by operational capacity and geography of trained technicians, and we have a lower margin. So we're probably going to transition this over to a franchise and reselling model and really focus on being a technology and platform company. So a quick word on traction. I mentioned already in the vertical side, we have quite a few pilots, quite a few commercial contracts already. We have 4 paid contracts and additional 6 LOIs and MOUs. The paid contracts include some single side pilots with energy utilities in Austria and the United States. And we have scaling frame commercial contracts with MEAG and Sixt. Our LOIs and MOUs include a residential energy supplier, 2 fleet mobility operators, including the largest fuel card operator in Europe, and go-to-market partners in Indonesia, Brazil, and Germany. So here's a little example of how our platform works. This is actually a success story for the platform, as our own customers keep finding better applications for our technology than we have in our own full service product. So here our customer is a company building a business around reimbursing employees for the power used to charge company cars at their private homes. And I have to kind of caveat by saying this is a very European business model, because a lot of people here get company cars with free gas. And so as people electrify, they need to find a way to kind of replace the concept of free energy by charging at home. And this is actually a hard business, because the period of time over which fixed costs are amortized is the length of employment. And with legacy technology, we have thousands of euros paid by the company, often to reimburse less than 100 euros of electricity per month. And if the employee leaves the company after a year, all that money goes down the drain. So for customers like this, we're actually taking what is an unprofitable business model and we can make it profitable. And so we actually have a few customers with exactly this business in our sales pipeline. Just a quick word on the team. We have a team with some extraordinary credentials across the EV, general automotive, and connectivity, global tech spaces. I started with electric vehicles at the University of California, Davis, about 20 years ago. And once you drive an EV, you can never forget it. So I always knew I'd end up starting a company in the space. My co-founder, Robert, he was also an early arriver to the EV space. He worked on public charging infrastructure way before it was cool for a Japanese company called NTT Data. And later on, he worked on exactly these kind of connectivity issues that we solve at both Sixt and BMW. Our team provides a ton of software delivery expertise between front-end, back-end, mobile, and embedded. And we work closely with hardware design houses and ODMs on the hardware. I should actually note that we have a beachhead go-to-market team for the US. One of the people is already on the slide, and I can't give the name, but we have a big name from the energy industry joining us very, very soon to help with US go-to-market activities. On IP protection, we have basically our core and most strategic IP is CARIAD, and this provides our unique and protectable cost, scalability, and user experience advantages. And we have basically a global coverage in the works for that. We also have the HeyCharge brand protected across Europe. And just a quick note on our funding status. We recently raised a $4.7 million seed round. It was led by BMW iVentures. That's the corporate venture capital firm of BMW. The round included a number of other institutional investors, including some major names in energy, such as Statkraft Ventures, who have a portfolio of EV charging brands across Europe. I think that's it for the slide deck. I'm also out of time, but I'm very happy to answer questions at the appropriate time. Thank you.
Yes, you are, Chris. I mean, there was a lot of information, but it was also such a fantastic story from starting with one problem and then ending up with a whole solution platform. So we will come, I'm pretty sure we have some questions later. So we will come back to HeyCharge. Before we do that, we kind of stay in the e-mobility space and maybe not. The next technology on the stage is from Betterfrost Technologies, and kind of Derrick Redding, that I already call on the stage, is working on solving a different problem. As if I charge an electric vehicle and I can store the electric energy in a perfect battery, maybe from Enzinc, I still have the challenge that I might have a limited range. And the technology from Betterfrost is piece to the puzzle. So I will not disclose more and give the stage to Derrick.
Great, thank you very much, Fabian. Pulling up my presentation now. Can you see this okay?
Yes, just perfect.
Great. Well, thank you very much for hosting this event today. My name is Derrick Redding. I'm CEO of Betterfrost Technologies. We're based in Oakville, Ontario, just outside of Toronto, and we developed a ultra-low energy solution for defrost and defog in electric vehicles. So I'm going to talk about range anxiety, the fear that an electric vehicle will run out of charge before reaching a charging station. This is an important challenge for our industry because it's a consideration for consumers that are considering to buy an electric vehicle for the first time. And unfortunately, driving range is much lower as it gets colder. So today I'm going to be describing a transformative technology that Betterfrost is bringing that will help extend range and reduce range anxiety for drivers. Electric vehicles face three significant issues related to range in electric vehicles. The first is that the current HVAC system is old and complex. It was built around the internal combustion engine when we get a free source of waste heat. Well, that free source of waste heat is no longer available, yet we're still using the same architecture to deliver defrost and defog into the vehicle. The second major problem is that the range of an electric vehicle is very sensitive to temperature, and range drops significantly as it gets colder. In fact, it's 20% for each 10 degrees Celsius drop in temperature. The third major problem is that EVs cost much more than a comparable gas engine, about $10,000 more, and that cost difference is all due to the battery pack. Our system is based on decades of research from the Dartmouth Ice Lab. There they studied the way ice forms, the way it adheres to surfaces, and the most efficient way to remove it from surfaces. And their key insight was that if you control the penetration depth of the heat, you only need to melt the interfacial layer of the ice. And this is only about 1/10 of a millimeter, so it's very thin. And if you create that layer of water, it makes the ice available to slide right off it easily without having to melt the entire mass of ice. The second insight they had was that if you provide high voltage pulsed electricity, that's the most effective way of controlling that penetration depth of the heat. So we've taken these ideas and we've built them into a controller that we put into an electric vehicle, and we provide this high voltage pulsed electricity into the conductive layer in windshields. This conductive layer is now being added by the windshield makers in order to reduce solar gain in summer. And this is typically silver or FTO, also called fluorine tin oxide. So those metal layers, which are completely transparent, are across the entire glass surface, and we're charging that with our solution. This next slide shows our value proposition, and in testing, our system improves range by 38 kilometers more on an average drive in winter compared to current HVAC systems used in an EV. And that 38 kilometers per day is worth about $600 per vehicle of battery pack cost. Now, to put this savings in perspective, when I used to work at Toyota Assembly, it was a good savings if we reduced 25 cents per vehicle. Later, when I worked at JCI Seating in product development, only twice did I work on projects that saved $10 per vehicle. So to be able to save $100 per vehicle, let alone 600, is a big deal. And this is something that immediately gets the attention of the chief engineers, the automakers. Now, in company testing or lab testing, our system requires much less energy and much less time. In a common regulatory test, FMVSS 103 shown here, in an A to B test, our system is taking under 1 minute compared to about 15 to 20 minutes for current systems. And now currently the automakers are testing the system and getting similar results that we're getting in our test lab. We've also conducted hundreds of tests in the lab. These include regulatory tests, A to B comparison tests, comfort tests, electromagnetic compatibility, and also deep cold tests going down to -40°C. What's also interesting is our system actually works better the colder it gets, and that's because the current HVAC system is so inefficient and takes so much energy. Our system significantly improves it. So in the graph on the right side, the red line shows the current, an EV with the current HVAC system. And in a 64 kilowatt pack application, our system at -20°C would actually increase range by 15%. And as it gets colder, that increase actually goes up. Now, no one is doing what we're doing. This chart compares our technology to the current methods for defrost from the HVAC systems that are currently in place today. And based on our testing, we're able to defrost the windshield with 20 times less energy and 20 times less time. So this isn't just incremental improvement, this is step change, transformative improvements. In traction, we've been doing very well with customers. So far, we've completed tests at 2 OEMs and 1 global tier 1. And right now we have scheduled additional tests coming up in the next month and a half at another OEM and another tier 1. On patents, we have 12 granted so far. And just recently in April, we're very proud to announce that we won the GAMIC competition along with the others on today's call at the SAE World Congress back in April. Here's a picture of our demo vehicle that we're providing to customers for testing. And this has our system installed and a glass that has the metal layer added to it. For a total addressable market is large. Our entry point and beachhead market is the EV market space, the luxury EVs. And the global TAM for cars is over $2 billion. And with other markets in refrigeration, our TAM is over $4 billion. And our carbon reduction potential is over 62 million metric tons per year. Now, in this chart, this shows a typical go-to-market strategy or a typical innovation process that we're all aware of for bringing a new technology to market. The left side shows the R&D phase, and the right side shows the model development cycle. So currently we're in the middle. We started 3 trials. We expect to have these trials completed this year, and based on the strong value proposition that we offer to the OEMs, we expect to receive our first customer award next year. We also plan to partner with a global tier 1 to help scale sales and for product revenue to start from 2025. On our team, we have deep automotive and R&D experience. Myself, I have more than 2 decades in automotive. I've also worked at mobility startups where I've raised money and also brought innovative products to market. Previously, I worked at Toyota in assembly and JCI Seating in finance, business development, and product development. We have a very strong engineering team that's very diverse. Our CTO is Sammy Sad, who has 15 years of R&D experience and a PhD in mechanical engineering from Toronto. And our advisors also bring deep automotive and business experience. So with that, I want to thank everyone and look forward to any questions you may have at the end of today's presentation. Thank you.
Thank you, Derrick. Another fantastic example how long research in materials and surface physics finally pays off and delivers a great new solution and technology. And I believe that's something that Betterfrost and our next presenter from Coded, Katarzyna Zielińska, has in common. They also came, I believe, from a long research of not just material physics, but also chemistry. And she will now tell us a little bit more about the technology and also the business model of Coded.
I hope that you can see my screen.
Just perfect.
Great. Hi, my name is Katarzyna. I am CTO and co-founder of Coded, and thank you a lot for hosting us today and giving us opportunity to show you how our technology can help to meet performance and sustainability goals in the automotive coating industry. Few years ago, Toyota had to recall 466,000 vehicles for corrosion and brake pedal problems. Recalled cars were unsafe to drive. Recalls like this means hundreds of dollars for repairs and usually mean legal costs and damage to the brand image. But corrosion and wear are not only expensive problems to automotive industry. They are putting our lives at risks. They are causing accidents and they are making our cars to cost less. And because of them, around 10 million tons of steel ends in the landfill in US only. Corrosion costs automotive industry in US around $23 billion. And recent recalls conducted by Ford, Honda, Mazda, and Chrysler show that the problem is really global. In average passenger car, we have around 3,000 metal-coated parts. So not wonder that it's quite a serious problem causing a lot of issues. What could we do about it? Imagine that construction materials like steel, aluminum, and magnesium alloys are like donuts. They are okay, but they have poor surface properties and corrode fast. To avoid that, the coating, like an icing on the donut, is put. It slows down corrosion. However, standard protective coatings are often not enough, and the coating industry is still using a lot of toxic substances. At Coded, we are adding small amount of nanomaterials to this icing and making the nanocomposite coatings. In the standard metal plating process, you have the metal ions dissolved in the coating tank. Those metal ions, driven by electricity, make a thin metal layer around the coated object. At Coded, we are taking a standard coating process and introducing to it the coating additive in the form of water-based dispersion of nanomaterials. Thanks to the special surface functionalization, we have in the coating tank now the dispersed nanoparticles, which then they are able to get into the metal matrix, giving rise to nanocomposite coatings with superior anti-corrosion and mechanical properties. But what is more, when we choose the nanomaterials carefully, we can make those coatings smart, for example, super hydrophobic or self-cleaning. And speaking about nanometer means 1 billionth of a meter. Imagine average height person reduced in the size to 4 nanometers. This is how big our nanoparticles are. But actually imagine 7.9 billion people, the whole population in nanoscale. When reduced to this size, we will all fit to the one single truck. But nanomaterials are not only about size. Let me introduce you to Tony Stark, the great scientist, but besides of that, ordinary man. However, when he puts his suit made out from titanium and gold nanoparticles, he becomes a superhero with superpowers. And the same situation is with the materials. When going from the macroscopic to the nanoscale, they are getting some superhero capabilities. They have very high surface area, high enough to make the Iron Man suit. They have high surface energy and unique chemical, mechanical, and optical properties. The coating nanoadditives introduce those special powers to the coatings and mean longer product lifespan, lower cost of repairs, safer vehicles, and less metallic waste. but coated can do much more. For example, we are able to use thinner coatings and provide excellent anti-corrosion properties. In case of car manufacturers which pay hundreds of millions of dollars, for example, for nickel, it will mean serious savings. Let's take Toyota case. If they will use our technology, they could save around $47 million just for nickel paid to coat in their cars. But in the same time, they could save around 50% of CO2 emitted from the electricity-driven coating processes. You all probably heard about chromium. It's a pretty toxic element. However, it provides nice finish in coatings and gives excellent anti-corrosion properties. It is used, for example, in zinc passivation solution. Using coating additives, we can reduce significantly the concentration of toxic chromium, create superior anti-corrosion properties for a lower price. Performance of our additives was tested by independent labs and by our clients which run pilot tests with us. One of such trials was on the headrest for BMW cars. I know, headrests may seem quite irrelevant element, but they can really spoil our experience with the brand new car. Each headrest, but actually the coating on this headrest, need to be resistant to wear, have excellent anti-corrosion properties, and it needs to serve as well decorative purpose. So quite demanding task. As shown in the accelerated corrosion test, with our additives, we can get superior anti-corrosion properties, slowing down corrosion around 2.5 times. We are working as well on the new generation of smart self-cleaning coatings, and we are developing as well coatings which provide excellent anti-corrosion barrier for EV batteries. To summarize, with our nanomaterial-based additive, we can help to meet sustainability and performance goals in the metallic coating industry. We can bring serious savings to the coating industry, and we can bring them to the new smart level. Our corrosion fighting team includes scientists with deep scientific knowledge of protective coating and nanotechnology, business insights, and professional administrative and technical support. We are supported as well by administrative, tax, health and safety professionals. We have investors on board. We secure our funding from European funds, and we are taking parts in accelerated programs like Plug and Play and events like GAMIC to spread a word about the technology which coated can offer. When comparing to traditional coatings or to our competitors, which offer the nanocomposite coatings additives, solution provided by coating can be tailored to many plating processes. Our products not only improve the mechanical properties, but as well the anti-corrosion properties. But what is the most important, we are make the coatings, the smart coatings, giving them new functionalities. We are selling our additives to 3 groups of clients: companies which provide components for coatings, plating shops which make coatings, and to OEMs, those which have the capability to make coatings by themselves. We really believe that with small, but actually nano changes, we are able to create safer, smarter future for all of us. So what is more to say? Just coat it and contact us if you are interested in our technology.
Thank you, Katarzyna. Thanks for the presentation and for the great insight in your technology. Let's bring all the speakers back on this virtual stage. I have to say, I hate virtual events and I love them. I hate them because for one main reason, because normally when you take the stage and make a fantastic presentation, then you get a great applause. So I do this now for the rest of the audience. So thank you so much for presenting today. What I love about, definitely love about our online format in the new world, that we really can come together, have great speakers from all around the world, almost all around the world. So next time we need another speaker, maybe from Japan or China. We will work on that. Before, please also to the audience, you can still post your questions and we will address them in our discussion. I'm not so sure if I have all the speakers. Yes, I now have all the speakers on the screen. So let's start with a few follow-up questions. And I would like to start with Chris, because HeyCharge already kind of went through this hard time of pre-seed phase. And we've seen it so many times. There are many up and downs. So can you share maybe the hardest, the toughest point in your pre-seed phase? We say, oh, we're really struggling. I don't know if we can really make it. How did you overcome it? How did you power through? How did you make it out of this sometimes very, very challenging pre-seed phase?
You're probably gonna have to stop me from talking because this could turn into a really long story.
Oh, but just one. Just give us one example.
All right. The high level answer is that we originally actually formed the company before we recognized the problem that resulted in the development of our secure charge technology. So we actually thought we would be a software company, basically developing software that would run off the shelf EVSEs, chargers, wall boxes. And we funded the company, pretty generously to accomplish that goal. And then along the way, when we realized, okay, well, we solved a pretty good problem, but we kind of missed this really big opportunity to solve the connectivity gap. That basically meant that we had to develop a new end-to-end technology, and kind of by, I think I mentioned this in the presentation, kind of by extension, we had to then start developing the hardware. All of a sudden, we turned from a software to a hardware company kind of accidentally. And then, I shouldn't say software is easy, but it's easier than hardware. We were kind of stuck with this idea that was, kind of lacking a proof of concept, a proof of feasibility, as we are slowly running out of money. And the investors really very much wanted to see, does this thing work? Are these guys selling snake oil? And so there were some desperate days when we had some great slides, but, nothing worked, right? And we were still basically selling an idea. We would not have made it if we could not convince people. But actually, the people we ended up convincing were our own employees to basically join us with no salary, and some hardware partners who basically agreed to build our POC prototypes, essentially at zero upfront cost. So we were able to basically translate this into a development agreement that, translates into essentially royalties on devices produced. And so we were able to slow our burn and get the product over the line and working. And you could see, like, the first time I showed up to a meeting with an investor who I'd met them 5-6 times before, they're like, blah, 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 whatever, we don't believe you. Then they see the product working and, like, the eyes light up, right? And that was the moment that everything changed for us.
The moment everything changes. Maybe I hand this a little bit over to Michael. Your presentation was fantastic in terms of, wow, this is really scalable. So you can really replace not just existing technology, but really even reuse existing production facilities. But every also mobility and technology startup has to start somewhere. And sometimes I believe you have to start in a niche kind of product. And it's sometimes, I don't know if an inventor can really define the niche where to start, or the market finds the niche. So how much do you think are you in control, and how much is the market also steering you? The more you take the stage, the more you're influenced by your discussion partners.
Oh, excellent question, Fabian. So it is kind of, it's a large niche, by the way. If you take a look at, like I said, just the lead acid battery market alone, that's several tens of billions of dollars. But every startup has to have a beachhead to get into. So first, what we did is took a look at who actually needs this technology, right? Not just wants it or is interested in it, but who actually needs it. The second part was, which market can we get into that is small from an engineering point of view and a testing point of view. So we did a market study, and then we approached several companies, and one of them is this e-bike company, one of the largest in Southern California. And as most of the fellow startups, you go through a questioning phase, talking to your customers a lot, and you end up getting answers that surprise you. And the one that was our surprise in that particular arena was safety. We thought it was in terms of performance, and they came back and said, no, what attracts us is safety. So you're absolutely right. You have a piece of technology, you've got a solution, but then you have to spend time talking with those potential customers to narrow it down to what's your beachhead market that then allows you to validate and demonstrate that particular product so that it then spreads to other adjacent markets.
Yeah, no, it's interesting that you say that, because you need to have one first revenue stream. Absolutely. When we compare this a little bit also to the technology that Derrick presented from Betterfrost, I believe Betterfrost always had a very clear roadmap, a very clear solution focus. Or maybe I'm wrong and you can correct me, Derrick. But what was interesting to me, and you did not mention it directly, but I remember from our discussion during the GAMIC finals week, did you say you made some major progress, even with an automotive OEM? And most of us here and maybe also in the audience know how difficult it is sometimes to open these doors, these big doors of automotive OEMs. So what's your secret sauce? How do you, what is so far your recipe for open big doors on the way that you have performed in the past and also moving forward?
Yeah, I think there's two things that have gotten us this far. And let me add to that. This, having been involved in product development and innovation for more than 2 decades, I know how long it takes to bring a new idea, and even more difficult than innovation, into automotive and all the testing. It's a very complex vehicle that takes a long time to evaluate, develop, and launch. And compared to my other startup experience, I've just been very, very impressed with how quickly we get the attention and those doors are opening up to the testing. And when I look back at, why have these doors been opening, I think there's 2 key things. One is the technology works, and it's based on just very sound research that took more than 2 decades. I mean, at Dartmouth, and then Kazi, who's the other co-founder, was responsible for helping to bring this out of an academic setting. And the team's been working for a long time in terms of how to build the hardware to be able to actually implement this with software in a vehicle setting. And then the second thing I think is just connections, whether it's myself, our advisors, or we also have a strategic investment from Toyota 2 Show, which is a trading company, part of the Toyota group, but it's not the same thing as Toyota. These different ways have been opening up doors, and then the GAMIC competition would be another one that I also have to recognize too. It's been very good for exposure, doing World Congress, and having a display there at World Congress. All these things together have been opening up these doors. And it's also nice that within a few hours we can set up and test. So it's not long-term durability testing, it's a few hours and the results are immediate, and it's pretty satisfying when senior R&D folks are coming into the test lab and just huge smiles on their face when they actually see it work and replicate the results of our own internal testing.
Yeah, we are all kids. It's always great in the end when we can touch it and see it work. And I think Katarzyna, what you showed, just an example with the headrest. Now everybody will go back after this meeting in their own car and say, "Oh yeah, well, this is how it looks, and do I really have like little notches on it, or how does mine look?" So I think this is always very important. As I'm talking to everybody from Berlin. I believe you're not that far also in Europe at the moment, or you can correct me. So I have another question more on a global scale. when you try as a startup to attract different markets, and for Coded, it's bringing a new material in the coding process in a lot of different facilities around the world. Do you feel also the cultural differences, or how easy is it to get into these facilities, into the discussion, maybe when we compare Europe to the US? And where do you think in the future your market will accelerate the fastest?
So for metallic coatings, North America is the biggest market. Then the second is Europe. So of course, in the US, there is a lot of potential for our technology, and a lot of our potential clients are based there. And with events like Plug and Play, GAMIC, and you hosting us today, we hope actually to be able to now go through those doors and have our presence there, because definitely there's a huge potential. But as you mentioned, we are based in Europe, not so far from Berlin, in Poland actually. And for us, it was natural to take our first steps here in European market. But as I said, we are aiming actually for global presence, Europe, American, then maybe Asia as well. And do we see cultural difference? There are some, of course. However, our team spent a lot of time outside Poland in different countries. We've been working as well for American companies, so we know the style a little bit. And as well, thanks to GAMIC, we are talking with people which could be our representative in US. So I hope that we will manage to get there.
Thank you so much for your answers. I believe I would have many more questions, and I wish we would have more time to discuss. But today's event is coming to an end, so I say thank you again to all the speakers. I say thank you to the SAE Section Detroit for hosting us today. If all you have any questions regarding the event or want to get in contact with some of the speakers, please don't hesitate. Reach out to events@saedetroit.org, and they will be happy to connect you and answer all your questions. Thank you so much. Thanks again, and I give you again my applause.
Thank you.
Very much.
Thank you.